Okay, so we're coming to the part now where we can actually review what we learned about quadratics. So this is going to walk you through some of those things. Okay, for number one, it said create a scatter plot and gives you a bunch of table of values. I went ahead and did those for you for A and B, just so you can take a look and make sure you're on the right track. So that's what your answer should look like. For the next question, it asks you to take a table of values, which they gave you, and then plot it. And I've kind of done this roughly by hand here. It asks you to figure out, okay, what do you think the y-intercept is by graphing, and what do you think the x-intercept is? And there's a couple of points of interest here. The y-intercept we can see right there is definitely at 0, comma 1. Definitely it's on 1. And the other one's a little bit tougher to see. This one is probably about 2.5. And the other spot it crosses the axis is probably about 0.5. So our x-intercepts, our best guess based on my not so perfect graph, 0.5 comma 0 and 2.5 comma 0 for my x-intercepts. Okay, good. So that was 1 and 3. For 4, we're going to expand and simplify each of these things. So we're going to use FOIL, which remember is first times outside times inside times last. All right. So the first thing we're going to do, we're going to do x squared minus 2x plus 4x minus 2. And if we reduce that and collect our like terms, we get x squared minus 6x minus 2. Perfect. For next one, another way of writing x minus 3 squared is just to say x minus 3 times x minus 3. And we'll do our first outside, inside, last again. We get x squared minus 3x plus 9. So if we collect our like terms, x squared minus 6x plus 9. Okay, again, we're going to use FOIL on our next one. We're going to get 2x times 2x. So first we'll multiply the 2's and we get 4. Then we'll multiply the x's and we get x squared. Minus 1 times 2x is 2x plus 6x minus 3. And we get 4x squared plus 4x minus 3. Last one, we have 3x minus 1, which is the same thing as saying 3x minus 1 times 3x minus 1. So we get 9x squared minus 3x plus 1. So we get 9x squared minus 6x plus 1 as our final answer. Okay, we want to just figure out what's going on in this shaded region here. So we got to figure out the area. And we know area is length times width. So what's our area? Well, we know the area of this big box is 12, and the area of this little box is x. So we want to figure out just what the area is here and here. So how do we go ahead and do that? Well, if we know the big one is 12 and we know this inside one is x, we want to just know the difference between them. So we want just the blue. So the way we do that, we can say our length is going to be equal to that 12 as long as we take away whatever that value of x is. All right? And since this thing is a square, we know that this is 12, and then we can say the exact same thing. We want to take that 12 and then just subtract whatever our x is. So we have our area for length, that one side, and area for width, or our formula for length, our formula for width, and now we can just say area equals length times width, so 12 minus x times 12 minus x, and we can just use our FOIL, right? So we're going to go first, outside, inside, last. 12 times 12 is 144, minus 12x plus x squared. Then maybe rearrange it so we're familiar with this format. So we'll move our x squared up to the front. We have minus 24x in the middle, and we have our plus 144 there. Perfect. For each polynomial, we'll find the greatest common factor, and then we want to factor it out. So what can we take out of 3x plus 18? Well, we can take the 3 out, and then we get x plus 6 left over. The next one, we can take a 5 out of both of those numbers, but we can also take an x out of both of those. So we'll take a 5 and an x out. What are we left with in the first thing? We're left with just an x. And the second thing, we're left with the negative sign for sure. We take out that 10 divided by 5, so we end up with 2, and we get rid of that x, and it is now gone. So we end up with x minus 2 in there. The next one, whenever you see this, you definitely want to check to see, can I get rid of that very first number? And here, we certainly can. So we'll divide everything by 3, and then we end up with x squared plus 3x minus 6. And now in here, we can factor again. And what we'll do is we'll try to find two numbers that add up to 3 and two numbers that multiply to negative 6. So two numbers that multiply to negative 6, we definitely have 3 and 2. We have 6 and 1. And I guess our only bet there okay, and for D, let's go ahead and try to factor that. So we can take a 14 out of both of those. We can also take an x out of both of those. So when we take that 14 and that x out, the first one we're left with still two x's, and then we're left with just a 2 on the last one. Perfect. 7, we have a rectangular playing field has an area that can be represented by this relation here. So factor the expression to find the dimensions of the field. Sure. So we have 10x squared plus 500x. I'm just going to make my pencil a little bit smaller here. So we're going to factor out, definitely want to start by factoring out that 10 and an x. So what are we left with? We're left with x plus 500. Awesome. So we have our area, and it's equal to 10x times x plus 500 in here for us. So what is our dimensions of our field? Well, if we draw this out, we can say this is 10x and this is x plus 500. So what's the expression for perimeter? And we know that perimeter of a rectangle is 2 times length plus 2 times width. So our perimeter is going to be 2 times our length, which is 10x, plus 2 times our width, which is x plus 500. And here, just distributive property, 2 times 10x is 20x, plus 2x, plus 2 times 500. So all we did there is just distribute that in. So it's 1,000. So we get perimeter equals 22x plus 1,000. So last thing we're going to do, find the area in the perimeter if x equals 10. Since I have my perimeter right here, no problem, I'll do that one to start. 22, and instead of x, I'm going to use 10 plus 1,000. If you do that on your calculator, it's going to give you a perimeter of 1,220. Yep. And then my area is 10x times x plus 500. So I'll do the same thing, 10 times 10 times 10 plus 500, and my area is 100 times 510, so my area is a lot bigger than that, 51000. Perfect. Looking good. For number 9, we want to factor each expression, so I'm going to do that in just a little space I have here. So the first one, and all of these we're going to do the same thing. We're going to find two numbers that add up to our middle, and then two numbers that multiply to our last. All right, so we have x squared minus 3x minus 18. So for that one, two numbers that multiply to negative 18? Well, we have 9 and 2, we have 3 and 6. I think 3 and 6 might work, so we have x minus 6, x plus 3 for the first one. For b, what are we going to get there? Two numbers that multiply to positive 18 and add up to negative 9, so we're going to end up with x minus 9 and x minus 2. For c, two numbers that multiply to 30 and add up to 11, so that looks like 6, positive 6, and positive 5. And then for d, two numbers that add up to negative 4 and multiply to negative 5, so we're going to have x minus 5 and x plus 1. Perfect, our factoring is done. Alright, so we have a little bit of problem solving here. So here's what we have. We have an arch, and we have a vertical support post going to be installed 36 meters from the base of the arch. How tall is the support post going to be? Well, they gave us that equation here, and all we're going to need to do is just plug in, because x is the horizontal distance, so it says it's going to be installed 36 feet, which is going to be our x, and then we can just solve for y. So we will, just in this space here, y equals negative 0.018, and then instead of x squared, I'm going to put that 36 squared plus 1.8 times 36, and then I will take out my calculator, and I will get cracking on this. So negative 0.018 times 36 squared plus 1.8 times 36 gives me a height of 41.472. Perfect. For 12, it says the path of a ball can be that is kicked can be modeled by this equation here. How long was the ball in the air? So how long was the ball in the air? You need to look at a little graph. So picture a ball being kicked. It's going to start off at the ground, and it's going to end up at the ground. So we want to figure out what is that here. Well, that looks an awful lot like our roots or our x-intercepts. So what we're going to need to do is we're going to need to factor this out. So we have h equals 25t minus 5t squared. So we're going to take out, it looks like both things can be a negative 5 and a t taken out. So if we take out a negative 5t from 25, we end up with negative 5. And then if we take out a negative 5t, we're left with positive t over here. So what are our roots? Well, this thing is going to be 0, right, whenever there's something outside. And this thing, what we need to do is we have to flip the sign. So we have negative 5 plus t, we set that equal to 0. And if we move that negative 5 over, we get t equals 5. So here's one root, and that makes sense, right? When it starts off, it's at 0. Here's the other root, it's 5, so we figured it out. How long was the ball in the air? 5 seconds. How long did it take the ball to reach its maximum height? So now we want to figure out in there what's going on. And for that, we'll use our formula x equals negative b over 2a. So negative b is going to be negative 25 over 2 times a, which is negative 5. And that will be negative 5 over negative 10, which is 2.5, which makes sense. It's right in the middle of 0 and 2.5. So it took 2.5 seconds. And how high was it at 2.5 seconds? Well, for that, we'll just put it into our formula. 25 times 2.5 minus 5 times 2.5 squared. So just take out your calculator. 25 times 2.5 minus 5 times 2.5 squared. And that gives me a height of 31.25. Okay. For number 13, we have Francis. He's got 500 feet of snow fencing to enclose a rectangular area for skating at a rink. Find the maximum area that he can enclose. Okay, so we have our area. It's going to be equal to our length times our width. But if we're looking for maximum area, our maximum area is always going to be a square, like we know. So we got to figure out, okay, we need our side lengths to be equal. So it's just going to be whatever our length is squared, because our length and width are the same thing. So area of a square is just side length squared. Now we have 500 feet to enclose this rectangular area. So that talks about our perimeter. So a little bit of a complicated question because you got to jump between area and perimeter. So what's the perimeter of a rectangle or a square? Well, we know that a square, since it has 4 sides of the same, is just going to be 4L. And how much perimeter do we have? Well, it says we have 500 feet. So 500 equals 4 times L. Divide this side by 4, divide this side by 4, and we get L equals 125. So each side is going to be 125. So what's the maximum perimeter that he can enclose? Or the maximum area? So area is going to be equal to our length squared, which is 125 squared. So if you take out your calculator and you do that, it's going to be an awfully big number. And our area is 15,625 meters squared. Okay, and our last question for this unit, sale of televisions. So they're selling 18 televisions at $440 per set. For every $20 decrease in price, you're going to get 3 more televisions. Okay, so if this is our equation here, we want to figure out what is our maximum revenue. Okay, well, you can figure that out. So to figure that out, we'll start off by figuring out what our x-coordinate of our vertex is, negative b over 2a. So we'll take our negative 960 divided by 2 times negative 60 equals, so we have 960 over 120 gives me 8. So 8 is how many televisions, or how many price drops, sorry, every $20 decrease in price. So this is how many price drops we need to use in order to sell the maximum number of televisions. So that does not tell us what the maximum revenue is. For that, we'll put it back into our formula. 7,920 plus 960 times 8 minus 60 times 8 squared. So let's take a look at that. 7,920 plus 960 times 8 minus 60 times 8 squared, and our revenue is 11,760. So what's the price per television in order to maximize revenue? Well, it says it starts out at $440. So our TV is originally $440. What happens is we have a price drop. We have a sale going on. And how much are we dropping the price? We said we're going to drop it 8 times, right? 8 times, and 8 times what? Well, we're dropping it by $20 every time. So we're going to take off 8 times 20, which is 160 from the price of TV. So after all is said and done, we get 440 minus 160. It's going to give me a price of $200.